In today's class, I will be solving a few more problem sums based on real numbers, LCM and HCF, which are of level 3. So let's get started. The first one says that a fruit vendor has 260 mangoes, 292 oranges and 220 apples. He sells each of these fruits in a package containing the same number of fruits of the same kind and has found that 4 apples, 4 oranges and 4 mangoes are left out. So what information we are getting from this problem statement? That the seller has packed same number of fruits of the same kind in every package, and after packaging 4 apples, 4 oranges and 4 mangoes are left out. Now the question is, find the greatest possible size of the package, where size of the package is defined as the number of fruits in each package, and find the number of fruit packages. That means when he is packing every kind of fruit of the same number, his aim is to accommodate more number of fruits of same kind in a single package, so that the number of packages will be minimum. That means here the number of packages is minimum and the fruits that he is packing of every kind in every package is maximum. And first we have to find that what is that maximum number of fruits of same kind that he has packed. So this is basically is a problem of finding greatest common divisor or highest common factor, because here we are packing every kind of fruit having same number, and that is greatest number. And one more information that we have obtained here, that after packing 4 fruits of every kind are left out. That means this 260, 292 and 220 are not completely divisible by that number, the maximum number of fruits that every package can accommodate. So what first we have to do is, we will subtract this remainder, this 4, from every type of fruit. So these are the number of fruits after subtracting those remainders or the fruits that were left out finally. And we have to find the GCD or HCF based on these numbers. Now what we can see is that 32, 36 and 27, they don't have any more common divisor. So the GCD of these three numbers will be 8. So answer of the first part is 8, and answer of the second part, find the minimum number of fruit packages. So when we will divide 256 by 8, and that means this value 32. Similarly, when 288 oranges were packed, and in every package when he kept 8 oranges, that means the total number of packages that the seller needed to pack all these oranges, 288, it will be, or he needed how many? This much, or this many, 36, this many packages. Similarly, when he packed 216 number of apples, and in every package when he accommodated 8 apples, then that means he needed 288 divided by 8, that means 27 packages. So these are the number of packages for every fruit, and we need to find the total number of packages that the seller needed to pack all these fruits. So the total number of packages will be, the answer of the second part or second question will be 32 for mangoes, 36 for oranges and 27 for apples. So when we sum them up, that gives us 95. So minimum number of fruit packages is 95, and in every package the maximum number of fruits that he accommodated was 8. The next sum says that Rahul wanted to type the first 180 natural numbers. Find the number of times he had to press the numbered keys. So first 180 natural numbers, and we know that natural numbers start from 1. That means first 180, so it will be from 1 to 180, right? So when we can divide this all these numbers, natural numbers, into 3 parts. So from 1 to 9 there will be numbers which will be of 1 digit, and for typing every 1 digit number he had to press a key only once. So for typing 9 digits he had to press those keys 9 times. Now let's consider the numbers which are of 2 digits. So from 10 to 99. Now from 10 to 99 there will be 90 numbers, and for typing every number, since every number is two digit number, so for typing every number he needs to press the keys twice. So since there are 90 numbers, so total it will be 180. And then the third part means all the numbers will be of 3 digits, so it will start from 100 and the last number will be 180. Now from 100 to 180 there will be total 81 numbers, and each number is of 3 digits. So if Rahul wants to type a 3 digit number, then he needs to press the keys thrice for typing every number, and there are total 81 3 digit numbers. That means in total he needs to press the keys 81 multiplied by 3, that is 243, this many times. And we need to find that how many total how many times he needs to press all those keys to type the first 180 natural numbers. That means we have to add all these values. So our answer will be 243 times for typing 3 digit numbers, all the 3 digit numbers, then 180 times for typing all the 2 digit numbers, and 9 times for typing all the 1 digit numbers, and in total that will be 432. Now the next one says the GCD, greatest common divisor of two numbers, is 17 and their LCM is 765. How many pairs of values can the numbers assume? So how many pairs of values? The given information are LCM 765 and GCD is 17. Now suppose we have two numbers A and B, and when we find the HCF value or LCM value of these two given numbers, what we do? We factorize. We try to find the common factors or common divisor, by which then we divide those two numbers. Suppose A is that greatest common divisor or highest common factor, and after dividing A by this small a, means the GCD, suppose we have this value B, this is the quotient. When we divide A by A, this is the quotient, and when divide B, capital B, by this A, then suppose we have the quotient this C. And since we don't have any more common divisor between this B and C, so we can say A is their GCD, and when we multiply A by this B and C, then that gives us actually LCM of these two given numbers, means capital A and B. So from the given information that we are obtaining from the problem statement, we can say that B multiplied by C, these two values will be in our case LCM divided by GCD, and that value is 765 divided by 17, so that will be 45. Now suppose if we factorize this value, 45 is what? 45 is basically the multiplication of these two quotients B and C. Now if we factorize 45, then it will be 3, then 15, and then 3 and 5. So these are the prime factors of 45. So 45 can be represented, we can say that 3 multiplied by 15, this is one way, then 9 multiplied by 5. So there are two possibilities that we can represent 45 as multiplication of their factors, so 315 or 95. Now suppose if we consider these two values 3 and 15, then what will happen? So A will be then what? A will be GCD value, means this A, and then multiplied by, suppose this is 3, so it will be 17 then multiplied by 3. And what will be B then? B will be again their GCD value, this is 17, and the quotient which is 15 this time, this value C, so it will be 17 multiplied by 15. And if we want to find their LCM, then it will be 17 multiplied by 3 and 17 multiplied by 15. So 17 will be their common factor, and then remaining the quotients will be 3 and 15. But still between 3 and 15 there is one more common factor, which is 3. And if we further divide by that, then it will be 1, and here we will have 5. So what we can see here is 17 is no more the GCD of these two numbers. Rather, the GCD will be 17 multiplied by 3. So it is not satisfying the criteria. And at the same time, LCM is no more 765, because 765 we get when we multiply 17 by 45. But this time the LCM value will be 17 multiplied by 15. So this combination is not possible. So the other combination is what? 9 and 5, this quotient's value. So the A could be 17 multiplied by 9 and B could be 17 multiplied by 5. And now if we want to find the HCF and LCM value, then it will be 17 multiplied by 9, one numbers, and 17 multiplied by 5, another number. And if we 17 is the common factor, what we can see, so the quotient will be here 9 and here 5, and between 9 and 5 there is no more common factor or divisor. So 17 will be in that case the GCD value, and 17 multiplied by 9 multiplied by 5 will be their LCM value. So this combination or this possibility is satisfying the information that are given in the problem statement. That means we can say that A could be 17 multiplied by 9, and in that case B will be 17 multiplied by 5. This is one possibility. Or else A could be 17 multiplied by 5. That is also possible. We can interchange these two values. So 17 multiplied by 5, and in that case B will be 17 multiplied by 9. This is another possibility. So these are the two possibilities that we can have if the GCD of those two numbers is 17 and LCM is 765. 153 and 85, or the numbers could be the another combination possible is 85 and 153. The next question says that if 4k plus 1 is greater than equal to 5 and less than equal to 49, this is one relationship that is given, then find the maximum number of co-primes formed from the possible values of k. Possible values of k. And co-primes, we know that any two numbers, if they don't have any common factor or divisor other than 1, then those two numbers are referred as co-primes. So from this given relationship, what we can conclude is that 4k plus 1, so on both the sides, if we subtract, means from all these values, if we subtract 1, then 4k plus 1, it will become then 4k, and this will be 29 minus 1. So it will be 4, and then it will be 4k, and then it will be 28. And then 4k, if we want to convert that to k, and if we finally want to have k in that form, then we have to divide by 4. So if we divide all these values by 4, then it will be 1, it will be k, and this will be 7. So what conclusion we can draw finally is k is more than or greater than equal to 1 and less than equal to 7. So this is the limitation of k. Then what will be the possible values of k? Between 1 to 7, any value. So from 1, 2, 3, 4, 5, 6, 7. All these 7 values are possible for k. Now, based on these possible values of k, we need to find the maximum number of co-primes that we can form. So when we will fix on 1, so if we take 1 as reference, then with 1, how many co-primes are possible? With respect to 1, all other numbers will have only one common factor or divisor, and that is 1 itself. So we can say that all other 6 values or all other 6 numbers will form co-prime with 1. So for 1, the number of co-primes that is possible is 6. Now we will focus on 2. So if we fix 2 or take this as reference, then we need to find that how many coprimes are possible which will form with 2. So with 2, 1 is possible, but that we have already considered when we found for 1. So we have to move towards right. We will not move towards left. We will not go back. For every value, every number, we will maintain that. So with 2, 3 is a prime number. They will form coprime. Then 2 and 4. 4 is a multiple of 2. So they will not form any coprime. But with 5, 5 is a prime number, they will form coprime. That means 2, 6 is a multiple of 2, not possible, but with 7, they will form coprime. So for 2 or with 2, there are 3 possibilities of finding or forming coprime. Then with 3, we will find with 3, 4 can form coprime, 5 can form coprime, 6 cannot because 6 is a multiple of 3. But 7 can form coprime. So that means with 3, the number of possibilities of forming coprimes is 3. Then for 4, 4 can form with 5, 4 cannot form with 6, they have common factor, and 4 can form with 7. So for 4 it will be 2, and then for 5, 5 will form with 6, 5 will form with 7, so that will be again 2, and for 6, 6 will form with 7, so that possibility is only 1. And for 7, since we have already considered all the cases for all other values that are before 7, so for 7 there is no more number left that can be formed with 7. That means the maximum number of coprimes that we can form from this all these possible values of k, that is 17. The next one and last one says that the LCM of two numbers is 1024 and one of the numbers is a prime number, then find their GCD. So LCM value is 1024. So what we will do first is we will factorize this LCM value 1024. And after factorization, what we can see here is the prime factors that 1024 has only one, because we can see here we have only 2 and then 1. Multiplication of all these 10 2's and multiplied by 1, but 1 is not a prime number, so only prime factor 1024 has, that is 2. And since one of the numbers has to be a prime number, so there is no other possibility that one of the numbers will be any number other than 2, and the other number has to be the LCM itself, that value itself. And now if we find the HCF and LCM, then see what happens. The common divisor will be 2, and here we will have 1, and here we will have 5 1 2. So the GCD value will be 2, and the LCM will be what? LCM is 2 multiplied by 512, and that is 1024. So that is satisfying our problem statement, that condition. And the second condition is the number, one of the numbers is a prime number, so that is 2. And since all the factors here are 2, so that number cannot be other than 2, because otherwise if we want to have LCM value 1024, then that number will become a composite number, that will be multiple of 2. So only possibility is this 2 and 1024, and between these two numbers the GCD value will be 2. This much for today's class. In the next class we will be solving a few more problem sums. Till then, stay tuned. Thank you.